Hello, my name is Mina, and I work for this awesome company. You know, I have been working with the software development for 20 years, mainly as architect who code and development manager. Now, I'm leading one of the development departments at NetEnt. I recently joined the company, and do you know why I like the company so much? Because of their organizational structure. We don't want to be a hierarchical company. We are too big to be a startup, so we are aiming to be a challenger. Meaning we are trying to combine best practices of culture of initiatives and culture of disciplines. We have a lot of self-driven, cross-functional teams. And now I know, you're thinking, why she's talking about our organizational structure when she's supposed to talk about the architecture? Do you know the answer? The connection between organizational structure and architecture?
Conway law.
Yes, it's Conway law, which says that organizational structure is always mirrored on the system architecture and vice versa. And such organizational structure enable us to build microservices. So we are now in the middle of transition to the microservices architecture. But today we are going to talk about something completely else. And in order to cheer you up, we will start with a short quiz. Are you ready for the first question?
Yeah.
It's about history of art. Do you recognize the building on the picture? Which is? Yes, Pisa Tower. Now I'm going to ask you several questions regarding this building. Is it architecturally perfect?
Yes.
From the technical point of view. Almost. But is it good enough? What is the most important property for one building? That is standing. And it was built in the 12th century and is still standing. So it's good enough. Does it create a value? Yes. You know, the entrance to the Pisa Tower costs 18 euros. It's a limited number of guests that can visit the tower. So many people are spending the whole day in Pisa, spending money in restaurants and so on, waiting queues to visit Pisa Tower. Yes, it creates a lot of value for Pisa City. And received versus delivered value? Yes, it costs a lot to maintain the Pisa Tower, and they had to reconstruct that. But it's still value that they are receiving from customers visiting Pisa Tower and Pisa City is much bigger than money that they are investing in maintaining it. Let's continue with the next question. It's about literature. Do you know who Richard Gabriel is? He likes to write poets, but it's only his hobby. He is a real software development guru. He has been working with the software development for 30 years, maybe even more. And when you visit his website, you can see both nice articles about software development and also his poems. It was 1990. Maybe some of you haven't been born. I see that there are a lot of millennials here, but he was working a lot with Perl programming language. And he was out for lunch with some colleagues, and they were talking, like spontaneous talk about different programming languages. And one colleague asked him, Richard, what do you think? Why do people prefer C than Perl? Because he really liked Perl and didn't like C. And Richard wanted to make a joke, and he said, you know, because worse is better, ha ha ha. And then everybody laughed. But when he came back to the office, he started thinking, maybe there is some truth in words that I said. Because he recalled many cases when some technically worse solutions were in fact better in practice, because they created a bigger value. So he published his article, Worse is Better. A year later, he changed his mind and published a new article, Worse is Better is Worse. In 1992, he changed back his mind and published a new article, is worse really better. In year 2000, he came with a new article, Back to the Future is worse still better. And the last article from that series of articles is Back to the Future, worse still is better. I really liked this article. These are such feeling good articles with a lot of good thoughts, so I suggest you reading them. But why did I like these articles? When I read them, they reminded me of my life experience regarding one area that is called model-driven development. So here it comes, my model-driven development story. Do you know what model-driven development is? It's a very nice concept. It's a way how you can separate your business solution from implementation techniques. So you model your business solution and describe it as a model. And from that, you implement code generators and generate code applications for different programming languages and different platforms. So it allows you, for example, you are doing some game and want to have a game app. Maybe you do that just for Android, but later on you want to have that on different other platforms. You already have your business solution described. You just add code generators and get a new application. So the logic is model once and generate everywhere. It sounds very nice. If you go a little bit deeper in details, how is it achieved? Usually it's not enough to have just one model, because you start with a model which describes solution on a very high level of abstraction. Maybe you have even meta model with some domain-specific language which describes your model or set of models. And then you are inserting more and more implementation details. You are transforming your model to platform-independent model, later on to the platform-specific models, and then you implement code generators which generate codes. Voila! It sounds really nice. It was year 2001 when I joined this company, which were building a database-driven framework for mobile and web applications. And they had this advanced architecture, 6 layers architecture, and everything was model-driven. So they have that entity layer model where they described their solution by using, it was XML with a UML profile, kind of a UML. They generated a database schema, skeleton for business object layer, application object layer, interaction layer, and then we have a user interface. It was a lot of XML trees and objects flying around. When I saw this architecture, it was, oh, wow, such an advanced architecture. It was year 2001, and it was not only architecture that was advanced in that company. They have already started using Agile principles. Do you know when Agile Manifesto was published?
2011.
1995.
Ah, close, but it was in fact in year 2001. And we have some pioneers regarding the Agile Manifesto, including my dear husband Gustav, sitting here, who introduced very nice Agile practices at that company. So we had a really 100% of unit test coverage. We did a lot of pair programming, although now I wonder, maybe he introduced pair programming because of me. You know, he was framework developer, I was application developer, and then he suggested that we should do a lot of pair programming, and then we fell in love. But let's leave that love story aside and focus on the architecture. So it was very, very advanced architecture, but unfortunately, it wasn't so stable. It required a lot of effort to get all those layers to be up and running. And also, we didn't have one single customer. But it was a little bit understandable because, you know, year 2001, IT crisis in Sweden started. It was really difficult to find customers. In fact, we had only one, but it was test customer who didn't pay. And what happened with this company? Went bankrupt, unfortunately. And I was thinking, oh, it's such such a pity, such a nice architecture. But it was a bad timing, IT crisis, so life went on, and I did some other work. In year 2003, I joined another company who was developing financial back office systems. And they said, everything that we have here, it's model-driven. I was a little bit suspicious, but when I saw the architecture, because I really believed in that model-driven concept, it's a really nice concept, then I was thinking, maybe this time it's going to work. Because it's the same concept, but it's not so complex architecture. We don't have 6 layers. This company was in fact a daughter company on one famous Swedish financial company. And after 2 years, they said, can you deliver something? And unfortunately, somehow, this architecture wasn't stable enough. So we couldn't deliver anything to production after 2 years. So the project was terminated. And then I was thinking, now I know what is the reason. It's that model-driven development concept. First time, I was just young and naive when I believed it was wrong timing. It's that model-driven development concept. It cannot work because it assumes such a big upfront design. You have to do a lot of modeling before you continue with the code generators and etc. Starting curve is usually too long because of that modeling. You're not producing anything for a long period of time. No return of investment. So I was thinking, MDD idea, it's theoretically nice, but it does not work in practice. And as someone said, the difference between theory and practice is much bigger in practice than in theory. And then I promised to myself, model-driven development, never again. Then I joined another company who was developing high-performance trading systems, transaction-based trading system. It was a very successful Swedish company, had a lot of customers all over Europe, and I was thinking oh nice, here everything that you code, it's going directly to production. Here you're not going to build something for 2-3 years without releasing to the production. And also system architecture was a little bit different. We had a lot of different components, and all of them were communicating between each other via an internally developed financial protocol, which was built on the top of TCP/IP. Not protocol, but messages. Protocol was implemented in that way that we had a lot of possibilities in creating messages. So each business solutions we modeled by the messages, so we introduce new type of messages almost on the daily basis. So it was a synchronous protocol, and we have a lot of messages, records, different type of fields within records. And it was almost every day when you had to add maybe not a new message, but a new field to the record, new enumeration, new attribute, and etc. And it worked fine for many years. System was developed in C++. All of our components were implemented in C++. Even message definitions were done in a C++ format. They were placed in a C++ header file. But as I said, it worked well for many years. But market is changing all the time. So we introduced new components implemented in C#, Java, all of a sudden Unix platform. Earlier we had only Windows platform. And all of a sudden we got a critical problem. Programming language dependency. Our message definitions are based on C++. What to do? So we realized we have to produce a new architecture for the message definitions. We have to change something. Of course, you always have several approaches. You can introduce a completely new protocol, maybe FixML, that is more standard protocol for financial transactions. But usually, design phase is long when you introduce something completely new. Then it requires integration effort because you have to change all existing components, how they are working with that protocol, and protocol replacement becomes difficult. Of course, you can refactor your existing architecture. Usually, hopefully, design phase is shorter in that case, and you can do it in that way that you don't change APIs, so that it doesn't require no integration or no changes in other components. When we presented that problem to the management, of course, they said, of course, we understand your needs, but you already have some working architecture. So can you do that, fast, cheap, and good? It's the best way if you can combine those three things. And of course, we know that it's impossible. But we were thinking, since we didn't have a lot of time to implement that, we were aiming to refactor the existing architecture. We are several architects who gathered together, and we use attribute-driven design approach to produce new architecture. We defined several quality attributes, what we really need with that architecture, which attributes are the most important. It was modifiability, usability, interoperability, reusability, and efficiency. Because, as I already said, these messages are updated and modified, inserting new messages on almost a daily basis. We also defined some architectural drivers to shape our architecture. It was centralization, data consistency, programming language independency, and presentation. And then we made architectural decision. Model-driven development is the most suitable for our problem. And then, what do you do in such situation? I have started screaming, oh no, haven't I said model-driven development never again? And really, what do you do in such situation? On the one side, you see that it's the most suitable solution for your problem, but on the other side, you know, it's not going to work. And first, at that time, I have started thinking about all other failed architectures. Maybe it wasn't model-driven development approach that was wrong. Maybe we did something else in a wrong way. So I have started analyzing failed architectures and to see what they learned from that. First, starting curve was too long. We can never reach production. We never received return of investment. Like, we didn't get a chance because project was terminated or company went bankrupt before we produced anything. We had a lot of waste in our system. We built complex architectures, a lot of features that were never used. We planned too much for future. So our focus was much more on building a perfect solution than on creating a value. And then I was thinking, what is the definition of software architecture? Now we are working to produce a new architecture. But what is definition? What is the most important regarding the software architecture? Of course, there are a lot of definitions, but this one is one that I like, proposed by IASA, International Association of Software Architects. Software architecture is the art and science of designing and delivering valuable technology strategy. And then I was thinking, since I became an early adopter of Agile principles back to the 2001, and from my experience, Agile and Lean principles helped me a lot in many situations to get some more lightweight solutions. And then I was thinking, maybe model-driven approach can be Agile and Lean. And I've heard some reactions. Oh, it's impossible. Such approach assumes such a big front-end design. How can it be Agile? And then I was thinking a little bit more, and I was thinking, what is the heart of model-driven development? It's accelerated development that is achieved by that centralized architecture that you have one central model, and automatic generations, and also separation of concerns between technical and business aspects. So you get much better business agility. What is the heart of Agile and Lean principles? Welcome changing requirements, delivering business value, eliminating waste, and deliver often and quickly. And when you see them, then you see that, in fact, they are addressing the same goals. To make system less sensitive to frequent changes. What is that? It's nothing else than achieving a business agility. That your system is not fragile, that you can change how market is changing. Accelerating development and eliminating waste. I was thinking, how we can apply Agile and Lean principles on that new architecture. Let's see what we have to do. First, we have these C++ header files that are in C++ format, definition files. So we have to do reverse engineering in order to extract the existing data. And we had a lot of messages, like 1,500 messages, equally many records, and different types of objects. If you go for the model-driven development approach, then we are supposed to have one model. Then we are supposed to have a platform-independent model to insert some implementation details. Then we have to have transformations and to have several platform-specific models, both for Windows and Unix platform, and then code generators that generate the final application code. If you think from the Agile perspective, you always think simplicity is essential. Eliminate waste and don't build for tomorrow. And then you see that complex structure of many models. But I was thinking, maybe we don't need so many models. Maybe it's enough to have just one model that is more like platform specific and put all platform related information in it, both for C++, Java, and etc. Then you end up that you maintain just one model, and it's much easier than maintaining several models. Okay, if we go just for one model, what should we use for modeling? UML is widely used, but in our organization, no one used UML modeling at that time. And then I was thinking, it's always difficult to introduce a new tool, a new way of doing things. It costs time and energy. Maybe some people are not willing to do that. Maybe for our needs, it's enough to use XML format. Let's go for that. You don't have to have some advanced modeling tools. Put it in a usual XML format. And also, code generators. As I said, from the beginning we had only C++ developers, but during the time we got Java developers, C# developers, C++. Which programming language should we use for code generators? If you think then collective ownership, we said, we can use just XSL transformations which will interpret that XML model and produce the final code. And then you are not linked to any of those languages that are using within the company. So what did we get by simplifying MDD approach? We get a perfection. As Antoine de Saint-Exupéry said, perfection is achieved not when there is nothing more to add, but when there is nothing more to take away. Of course, when you're simplifying things, you have to think that simple does not mean simplistic. So you should not remove things that are really needed. So that's why it's challenging to find that good trade-off. And of course, you have to think about your children when you are designing a software system. Because one day, maybe they are going to maintain your badly designed system. I've heard that from Bjarne Boström. Do you know who Bjarne is? The creator of C++ programming language. And he said, in fact, it happened to his friend. His friend worked for one bank for many years, and you know, time is passing quickly. 20 years later, his daughter joined the same bank. And after her first week at work, she came home and told him, "Daddy, how could you design that system in such a bad way?" So, of course, we have to think about children. So, we were happy with our decision. We are going to have just one model, use XML format to model it, and code generators will be implemented in XSL transformation. But it's just one side. We decided how our right product will look like. But there is another thing that is very important to think about, is how to build that product in a right way. Why? I like this Boyko Agic slide. Because if you are building the right product, but you are building it in the wrong way, you end up in a maintenance nightmare. Exactly what happened with us at that first presented company. The system was too complex, we couldn't maintain that. Maybe it was the right product, or it would end up as a right product eventually. But we built that in that way. If you're building right, but you're not building the right product, is a business failure, of course. So you have to think about all those two components, both to build the right product or right architecture, but also to build that in the right way. What does it mean? Did it mean for us? How to produce the new architecture? So we have three activities. One is modeling, our new model, which will hold all message definition information. Then we have code generators to implement, and we also have to do the reverse engineering. Where to start? If we start with modeling first, that feels like the most natural approach. First, I will plan my model to model them, and then I will insert existing data. There is a big risk that we build for future, that we specify things that will never be used, that we are going to introduce directly a lot of waste in our system. Should we start with reversing data first? Yes, but we cannot proceed if we don't have a model. You can extract the data, but where to put them? Code generators first, the same problem. We cannot proceed. You cannot generate code if you don't have the model and data. And I was thinking a lot that Agile, deliver working software frequently. And I also was inspired by a lean startup methodology proposed by Eric Ries about that build, measure, learn loop. You are building minimum but viable product. Then you measure and you learn from that you build and decide if you should keep doing that, persevere, or you should pivot. So I've applied those principles on producing our new architecture. Let's see how we did it. We decided to do all these three activities within the same sprint. So we started with the definition files, implemented methods for reverse engineering, so we focused just for one set of data, reverse them, put in the model, and design the model just for that data. So we are really focused, nothing more. Don't plan maybe to have some more property when a new record comes here. No, design model just for that reverse data. Produce code generators for the model data, and then run the code generation. And we had several programming languages, but output files for C++ files, then we compared the code with the code that was in definition files. Because in order to get the whole process being executed effectively, we decided that our control point is that generated C++ files must be exactly the same as C++ files as we had before. So we compared some part of the code and compared that part of the code. And then we continue. Then you take a new set of data, then maybe you realize in this model, oh, maybe it's not enough how I model. Maybe I should add this property more or this attribute more. Produce code generators and compare and so on. So adjust and factor, build, measure, learn, build, measure, learn. So I call it for Agile model-driven development. So we got a model that was pulled by the request. And we didn't introduce the potential waste in the system. It's much more that data-first approach, that you focus only on data that you have. And I really like what Stephen Perry said. All business have a cost, but waste is optional. And it is really very true. We are deciding how much waste we are introducing in our systems. And it's something that we can control. We didn't build for tomorrow. We were focused just do model code generators, but just for the existing data. And we also, by doing all three activities within the same sprint, we managed to produce a piece of working software in each sprint, so that the long starting curve was shortened. So as soon as we got a C++ generated file that looks exactly the same as our input legacy file, we just disabled the reverse engineering part, and then we got a new architecture in production. We didn't have to do any additional adjustments. So I was a little bit proud of this project because it was like my baby, and I was presenting it to all the new employees. And we got one senior architect, only very Java-focused person, and when he saw our good enough model, how it called, and he said, "Oh, you have merged platform-independent model and platform-specific model. Isn't it an architectural error?" Especially he got upset when he saw all those C++ memory locations that were entangled in the model, you know. And I'm a tough, but I'm a girl, so I was already starting crying. But I never cried. Do you know why? Because I remember what Eric Ries said when he introduced that minimum viable product concept. He said, it was so extremely ugly looking. I never wanted my family to see that we released such an ugly product. But it allowed us to get the feedback. And it was exactly what we did. We released something to the production. We had that good enough model that was ugly. But when it was in production, we had plenty of time to improve that without any stress. So after several build measure loop cycles, we got an ugly but good enough model which creates value. So if you take a look at that graph that we had before, nothing, you are sitting and modeling, but nothing is going to production, and start producing some return on investment, our curve looked like that. Maybe in the early beginning we didn't produce anything, but we went to production much, much earlier. And then at the same time, when your architecture is creating value and getting a return on investment, then you can improve that and refactor that forever. Why did we succeed the third time? What do you think? By accident? Third time lucky? Or because worse is better? No answers, you're tired. We managed this third time because we adopted something that is called the optimal solution proposed by Scott Ambler. Here is effort and value that you receive. When you are creating a product, producing an architecture, whatever you're doing, you're investing some effort in that work. And usually the value grows because you're working more on that and you're getting more and more value. But in one point of time, that value starts dropping down. Although you're investing more and more effort, it's not going to increase. It's like that maximum point. And it can be different scenarios. Maybe it starts dropping down directly, or it has a constant value, or it's constant for a while and then start dropping down. And the art and science is to capture this. Now I'm not using good enough, I think the better name is optimal solution, which creates maximal value for that effort. And you know, how can you capture that moment? You know, you don't have some red light that is saying, stop working, your architecture has just reached the optimal value. You know, you don't have signals. What do you think? How you can capture when you have just passed this maximum curve? It depends on your feedback cycles, because it's feedback cycles and retrospectives, how you summarize what you did. And the realistic is that you, or the best thing is that when you capture just when you have passed that. So we were really very happy with our optimal model, and then we used that for several years, but we wanted to have more. We wanted to achieve even better business agility, to be adaptable to change. So what was our new model, new problem? So we had that model in XML format. We generated a lot of files because during the time we realized that there is more and more need and more possibilities. So we did a lot of different things. We even did implementation for Google Protocol Buffer protocol in that way. So at that time, we also did the implementation of that protocol. So we had like 2 protocols that we could use. But the problem is, like, we had the generated files with these message definitions and different components which were using these files. They were compiled with that. But every time when you have a new files, each component must be recompiled and deployed to production. So if you have a new messages that we introduce to the system, you have to recompile, deploy, send to customer. Maybe he cannot replace that in production directly, as you know. And what to do in this situation? How to improve that it can be more DevOps all the way in some magical way. When I don't have an idea how I can do something in software development, I'm taking a look at the natural world because I think there are a lot of similarities between software development and the natural world. So I'm getting a lot of inspiration. And who is most responsible to change in natural world? Viruses. You know, they're changing their RNA all the time. You know that. So they're really responsive to changes. And then I was thinking maybe we can use that idea for implementing some new component, new virus, who can distribute in a runtime all our new message definitions. And we did that, so it's really a very nice project. So our new component, its RNA was all those generated files, and then we implement different APIs that are like wrappers that distribute that information from the generating files, and that are wrappers to different components. And the logic was like that. If you have at your customer different components that are compiled and they have that virus component, which contains different versions of message definitions, it's marked with that n-1 and so on. When the system is running, there is a mechanism in that virus that the one who has the latest version distributes to all other components the same version. So when the whole system is up and running, the new definition is just propagated like a virus in the system, and all components can understand that the latest message definitions. And we called our virus for well-intentioned minimum viable virus. Why is minimum viable? Because when we have started implementing that concept of distributing different things from our model, we realized we couldn't implement distribution of all things, all definitions that we have. Let's focus only on these that were most important. And it was, in fact, string constants and different text messages. Because it's really, we received a lot of value by doing that, because in that way, we could distribute that in an easy way without recompiling and deploying new strings. So that's why it's minimum viable virus. It doesn't contain all possible definitions from our model. To wrap up this talk, we are coming back to our philosophical question. Is worse better? Let's ask Richard Gabriel. What does he think nowadays? He says, I still can't decide. But if you ask me, with the 20 years of software development experience, I would say optimal is usually better than perfect. Not only that optimal solutions are lightweight, but usually they create much bigger value in production. So thank you for your time. So do we have any questions? Not directly.
No questions?
One question about the virus part at the end there. The APIs you talked about, when you upgraded with a new version, did you mean that you kept the APIs intact? Or?
Yes, because APIs, output parameters were arrays of the data. So APIs didn't change so often. It was just like distributing array of the whole, for example, record structure. But of course, when structure changed, then you had to change. So it was not the most ideal influenza virus, but it was.
Okay.
You had one question.
Would you like to comment for, say, a startup which is working on a problem related to healthcare, which has a direct impact on somebody's health, on, say, having a minimum viable product mindset to reach the customer, get a feedback, learn from it, you know, and then
Yes.
taking this concept into.
Yes, I would apply that concept in many situations. But I think many people, when you say minimum viable solution, minimum viable, many people focus on that minimum. But I think it's even more important viable, that is standalone, that you implemented something, that you are not just delivering something that is minimum. You understand? And of course it's the question, what you define maybe for different business domains. It's a different definition, what are basic requirements in order to achieve that minimum viable solution. But I would propose that build, measure, learn loop, and minimum viable concept, yes, definitely. Because it's the way how you get the feedback and how you learn things. Okay. One more.
Question. You said something about the organization being a part of being able to work agile.
Yes.
Because when you said that optimal solution, a lot of developers are used to quick fixes being consistent fixes. So do you think that was one of the reasons why you succeeded as well at the last part? Because you were allowed to actually continue to work with your implementation. So it wasn't like, okay, so we're going to implement this and now we're done.
Yes, probably you're true that we had that mindset that we are not just going to do one-off solution, that is going to live for much more years. Okay, thank you, and you can always come back to me. I'm here.